Hey, hello everyone. I think we're getting almost to the point to get ready to start. Just give it a minute so we can get a couple more people on. All right, let's kick off. Guess everyone came from their recitations. Apologies, last week, one of the sections, there was a issue. They ran the recitation the following day. They also recorded it. So both the TAs are recording their recitations. And, you know, on some situations where you have like, you know, the TA didn't make it to the class on time or whatever, you can feel free to jump into the other recitation. They're both covering the same material. So you can jump into that, or you can just catch it up on the recording also, okay? And as you notice, you also see from my lectures, I'm also recording. But I do try to encourage people to do some of the in-class work and try to turn it in pretty much ASAP, like right during the class or right after the class. So generally, I don't look to take in like the in-class assignments, you know, a couple weeks later, let's say. You know, and really the pace that the class is going, it doesn't do you much good to do the in-class assignments late, because I'm really trying to get you to do these in-class assignments to prepare you for the exam, right? And so you might have noticed, actually, if you look at the schedule for this week, we're here right now. You can see your exam is actually next week. Your first exam is coming up next week. And so actually what happens is today's lecture is going to get picked up, and part of like the next lecture, but mostly just this lecture is going to get picked up in the first exam. The latter part of the lecture on Wednesday is actually going to go into exam 2. Okay, you know, the time's going by fast. The exam 1 is already starting to come up. These little online work that I have you do, I'm not really correcting them, although last week I did spot a number of issues with the search where a lot of people were leaving a space on the minus sign for the not. So I did have to point that out. But in general, I'm not really scrutinizing all of your submission. The reason why I asked you to do this work is really for you to do some work, take some notes, and use those notes to study for the exam. As was pointed out at the beginning, these exams are open notes. So you can refer to your notes to help you do whatever on the exam. And I did clarify the point about you know, using calculators or using online calculators or using Excel or whatever. You're not allowed to do that. Okay, so please don't do that. You have to show the work and whatnot anyway. So, you know, anyway, as you get into like whatever questions you have, you look at the sample questions that are being, that have been posted out there. If you have any questions on those, pop into the TA's office hours, my office hours. My office hours are Friday, 3 to 5. If you want to pop in, just send me an email beforehand so I can lock up a slot for you. And we can cover whatever questions you want to prepare for the exam. So yeah, you can use the way I calculate with the formula, but you cannot use the Excel sheet. Okay, so yeah, so you have to show the work. All right, that's basically it. So the Excel is being treated as a calculator. Okay, that's the bottom line there. Okay, so let me go back to here and just to kind of, so you can see the course objectives here. And, you know, you can see I did the cross out here. Here's the chapters, right? So it's like chapter 2. Don't mind the weeks here because the weeks correspond to the normal fall, spring semester. But you can see all of these other things are relevant, right? So you have chapter 2 that you start off with, like all of these questions and whatnot. These are not questions to turn in, like I said before. It's really just for you to study. right? So if you have some questions on that, any of that stuff, just like shoot it over to the TAs or myself. We'll try to get back to you, try to put on Piazza if you can, and we'll try to answer any clarifications that you need on those. So 7 and 8, here's all the reading materials for that. And then here we got 4, 3, and 5. And vocabulary. There's some resources over here, text questions. And then this is where we start to cross over, right? So we have 4, 1, and 9, which I'm going to cover today. This is the rest of 4, which basically covers like the tables, lists, and CSS, the style sheets, right? And then 1 and 9, I'm not going to get to all of this today, I think, but I should get to most of it. And then we'll kind of probably pick up a little bit of it for the Wednesday class. So you can see all of these different things here. And then that's it, right? So that's for exam 1, right? But you might have noticed on this week's schedule, so you can see here, we're covering all of these chapters here. See chapter 10 and 17, we'll actually go over into next week, not next week, next exam, okay? So some of this stuff is really for next exam. Main thing you want to remember for this exam is the number conversions, how does like searching on the internet work, doing the HTML, doing like the digitization, right? So being able to look at sound, how do you digitize sound? How do you look at images, digitizing that, making like, you can call it special effects, or you can call it adjusting those things. How do you do that? Compression, perfect reproduction, lossless or lossy, copies of something like digital. Try to understand all those concepts, because those are really key concepts. They're important. They're going to be on the exam. Okay. So make sure you reach out to me if you don't understand any of those concepts, because they're like really important. Okay. Let's see here. And if you can see here, I went in here. Of course, here's the slides as usual. So I put in the slides. I made a copy of the reading resource, but it's the same thing I just showed you over here. This stuff here, it's the same thing. And there's a CSS tutorial that I put in here. The flowchart and pseudocode stuff, that's really for the second exam, and it's really for the upcoming assignment. I think all of you should have seen the assignment. So if I go here, and assignments. So you should see the assignment 1 in here. The assignment 2 will be coming up. So if I go over to here, so this upcoming 17th, you'll see the next assignment open up. Obviously, you're probably going to be more focused on your exam, but it is something that will be opening up available. These 2 assignments obviously are in scope right now, so get these assignments sorted out. So you have like the last week's assignment that opened up. The due date is the 20th. We'll accept until the 27th. Obviously, we're going to take half credit for that. Or if you want to apply your free late. If you apply your free late, make sure you give the TAs heads up before the due date. Do not like wait until the due date has passed and say, okay, I want to use my free late now. So if you want to use your free late, make sure you, so you let your TA know before that. Okay.
Professor?
Yes.
I have a question regarding the exam. Is the other stuff besides like the decimal, binary, and hexadecimal, is it going to be like multiple choice, or is it more of a like explaining type of thing?
So it's going to be a mixture of both. Let me see if I can get to the sample exam. Hold on a second here. Oh, let me get out of this student view. I thought I posted the sample exam up here somewhere. Okay. My section, let me see. Oh yeah, here's the exam 1 info and sample questions here. So we actually break it up into multiple sections. So let me get over here. So at the beginning part, it will be like some multiple choice, true, false type of stuff. So you should be able to bang that out pretty quickly. And then you're going to get into some stuff like this, where similar to like what we showed in that PowerPoint when I was doing the lecture. I'm not sure if your TAs did it, but within my lecture, it was sort of like this little grid type of thing. And it showed like decimal, binary, and hex. And then you kind of filled in all of these different empty spaces here. You're going to get something like that. I don't know if you call that short answer or something, but that's like one of the types of problems that comes in the latter part of the exam. The beginning part of the exam, you're going to be doing like multiple choice, true, false, or whatever. And the thing to remember on that is that you won't be able to go back. So once you complete the question and you move forward, you cannot go backwards, right? And like say, oh, let me redo that question again. So if you submit for that question, you have to be sure about it and then move forward, okay? You know, I was mentioning about the Venn diagrams with the searches. So you'll have some sort of search and say, okay, what is the Venn diagram that corresponds to this, right? Or in this case, they show you the Venn diagram and says, what's the type of search, right? So in this case, you have onions, pineapple, and ham, right? So that's going to be really, what is the set of results that you can do with your query such that you have onions, pineapple, and ham all in one shot, right? That's why you have this dark spot here where all three of them intersect. So that's going to be an and clause, right? So you're going to have an and, you're going to have onions and pineapple and ham, okay? And, you know, you'll have something, well, you'll definitely have some stuff like with HTML. So in this case, it's sort of like debugging the HTML. So you look at the HTML, you know, like I said during the lecture, a very common mistake will be like mismatched tags on your HTML, something like that. You're going to try to see if you can debug this and look for some errors there. You're going to have something like this potentially where you'll see like the page and then say, okay, what is the HTML it looks like to generate this? You can think, for example, maybe I'm going to give you like a table, or I'm going to give you a list, which I'm going to cover today. And you say, what's the HTML that's going to generate that table or list? Okay. So things like that. So yeah, explain how the page ranking works, you know, in the search that I covered the last lecture. You know, have a picture. How can I make the picture brighter? How can I increase the contrast, right? How can I increase the intensity of a color? And you have these things. What is the RGB value on these, right? Describe how to digitize sound, right? So, you know, that was kind of stuff that I covered last week. Here's tables and whatnot, which I'm going to cover for today. Okay, so I hope that kind of answered your question there.
Yes, thank you.
Okay, so take a look at this. Like I said, it's right here on my section here, my resources. You can see exam 1 info and sample questions. Okay, take a look at it, work through it. It's pretty representative of the type of questions you're going to probably see on the exam. If you're stuck on those, make sure you let us know. Okay. So you remember last week we were talking about spacing. Spacing is, well, there's a couple of things we talked about last week with spacing. So, you know, when you put the spacing in your HTML, it doesn't really mean anything, right? Like the rendering is just going to smush it all in. I kind of showed you that example where I kind of put things far apart and then it kind of brought them all back together again. So you have to use this explicit things like caret return to move things around and create like some spaces. So, or grouping things into paragraphs and whatnot. You can't just stick spaces in there. So, if you wanted to represent the picture, right? If the picture has like some carriage returns in there, then you have to put the carriage returns in there to create that spacing, right? If you don't do that, then that's an error, right? So that's not correct. Then the other thing I was talking about spacing where, someone was asking me about the indentation or whatnot in the HTML. That's all visual. That's only for like a person that's reading your code, right? Like I mentioned on the browser doesn't care. The browser could care less. If you just stuck everything on one line, it's just going to render it. So the spacing or the indentation on the editor, that's only for your eyes, for you to understand it better. Okay. Again, we'll cover more of that if people have more questions on that. But I do want to kind of get moving on this stuff because we have a lot of stuff to cover today. So let's get moving here. So first things first, let's continue on with chapter 4. So what I ended with last week was basically the intro to HTML. The last parts of HTML we want to cover, and I'll kind of just mention them quickly. Number one is this idea of styles, right? So it's referred to as CSS, right? Style sheets, right? Cascading style sheets. And it's essentially things like this, right? Talking about the color, whether it's the background color for the text, the fonts, right? Whatever fonts you want to use, the sizing of the font, alignment, like text alignment and whatnot. And there's a couple of different things on that, which I'll get into. So that's one thing. I want to get styling in here for today because styling is important. This is somewhat important, these escape characters. I actually find I don't use these escape characters all that much, but it is something to kind of know. So that's something we should make sure we hit for today. And then lists, right, is important. That's an important concept that's going to be an exam. So I'll have to make sure I hit that today. And including images, right? So like this R over here, right? And how do you align those images? Tables, right? Tables is really important. So we definitely make sure we have to make sure we hit that. So if I cover that for today, that covers all of this stuff for HTML. Okay, and I'm not sure why this tables is not highlighted, but tables should be highlighted here too. Okay. And there is some stuff to make sure you remember on absolute and relative path names. So if you didn't understand what I was talking about for last week about absolute and relative path, make sure you follow up with me. Okay, so let's go right back up to the top and let's see if we can work our way down here. Okay, all right. So W3 Schools is a good resource for HTML or for JavaScript, right? But in this case, we're talking about the style sheets. So like I was saying before, you address things like color, both on the text and the background, and like fonts and alignments and whatnot. That's the gist of it, right? And the important thing to look at is this idea of like they're essentially name value pairs. In this case, they're calling it property value pairs, but essentially they're pairs of stuff, right? So in this case, an example here saying, well, here's your color. Well, what color do you want? Well, in this case, they're saying red, right? So this is an example of different types of styling that you're going to apply, right? And so normally before when we were teaching you introductory HTML, you would see like bold, right? So you would see like this B here at the beginning and then close with this greater than sign. And then you have whatever you have inside your element that you're going to make bold, right? And then you close it off with the /B tag here. Now what you're doing is within this, you're going to apply your style. So in this case, we're talking about, well, I want the color of this to be red. By the same token, I could have put like the font in here. I could have put the font size in here. And I could have put in like the background color for this, which you'll see down here. Okay. And really quickly, let me see, I think I have it here. Yeah, so I have some stuff here for sample style. Okay. And So what we're showing right now is where you're applying it, what they call inline, right? Inline means here's like what I was saying, here's your B, right? Nicely, my editor kind of highlights the open B and the closed B here for your bold. And then within here, yellow, this is your styling, right? So this is what they call inline styling, right? And when it's convenient when you have some tag that you can stick this into. In this case, is your bold, right? But if you don't, let's say you just have some regular text, right? So you have this, right? Veni, and you want to apply it, but you say, well, I don't have any tags around it. That's when you use something like span, right? That's what the purpose of span is for, right? If you don't have something like this B wrapping around your text here, but you need to get that so you can stick in your styling, then that's when you use span. Okay, so you can take this as an example here, right? And let me go back to here. And which one is this one? This is sample style, sample style. Okay, and it's really, just kind of showing what I just showed you on the text here, right? So all these different stylings that you're applying here. Let me go back to here. And notice, again, like to my point earlier, if you don't put in stuff like your carriage return, like this BR here, it's just going to line up one right after the other, right? And, I did it just so I can see the difference between like putting in some style, in this case, no style, in this case, putting in some style with the background color and the font size. I put in these BRs to separate them, like you can see here on the left, right? But like, what happens if I just take this out, and take this out, and then I refresh this, you see it just kind of jams it all into one line, right? So that's why you have to put in like these other tags to create spacing. Let's see here. Okay, so let me see here. Yeah, so this is like styling, and this is what they call inline styling. Okay. All right. So what does span mean? Well, I don't know, like span, like I was saying, span is just like something where if you don't have like this tag here, like a bold in this case, and you can't just like put a style in the middle of nowhere, right? So I can't just do like style, whatever, and then put some text next to it. So it's a way of allowing me to put style in here, like to give me a tag essentially to stick style on something. Okay, so like in this case, it's the Veni, right? So this Veni here, without this other tag here, I can't do anything. I can't apply a style to it. Okay, so by putting in this tag, you can almost say like this span is almost like a placeholder tag to allow me to do things like style on it. Okay, span by itself doesn't do anything, right? Span is just like a container to hold the different styles that you want to apply against this text that's inside the span, the element, right? Inside the span, right? If you remember earlier on, I was telling you, these are tags. This is the element, okay? So that's why you have a span, okay? Let me get back to here. Where am I? I'm on chapter 4. Yeah, okay. So these are tags, not tags, styling, and it's inline styling, okay? Oops. Oh, and here we go. So if there's no tag, how do you add a style attribute? Well, that's what we have span for, right? So that's why I put in the example with the span like this, okay? So let's roll along here. So now this is where we put the same type of concept of like styling, and we put it like into the top part of the HTML, right? So you can imagine, let me go back to here. Imagine like, let's say whatever like common types of things, like let's say all of the headings or whatever that's in my HTML. And let's say I have a very long document, like I have a whole bunch of like paragraphs and whatever, like it's really long. You're going to probably kill yourself if you're going to use inline styling and put in, or you're going to do a lot of copying and pasting at a minimum, right? So you're going to be doing a whole bunch of inline styling. That doesn't really scale, right? And that's why you get into like putting the styling in the head, okay? And so what does that mean? So I can specify once at the top in the heading, let's say anytime I use the tag H1, I'm going to have these type of attributes or these type of styling, right? So I want the color to be gold and I want the text alignment to be center, right? So I don't know, like H1 means like, you know, that's like the focus, your center of attention. So bang, like anytime you use the H1, that's what you want. So that's way better than inline styling where I would have to type this like every single time I use the H1 tag, right? So this is kind of a way to save you a lot of typing, right? To make things a lot easy. And then, you know, let's say later on down the road, you say, you know what, I don't like the color gold for the heading. Maybe I want to make it, I don't know, red or black or something, right? I can change the color in one place and it will like cascade to everything else, right? So that's like the next step up in terms of scaling this up to make it a lot easier for you. So you don't have to type in all of this styling one by one, let's say. And, you know, to my point, when you make this one change, it goes out throughout your whole HTML document, okay? Now, the next step above this is the CSS file, right? When you include the file will actually be something you link to within the head. That means you can have multiple HTML pages pointing to just one CSS file, and then you'll get the same benefit of scale. So if I changed it into one place, all of a sudden, like, you know, let's say my document, let's say my website has like, you know, 20 different pages. Bang, in one shot, I get like all of the pages on the website by using the style sheet. Okay, so I refer to the style sheet. I can type it in once. I can get the same style. I can get a consistent style across all of my documents that are referring to that. And then, you know, if I make a change later on, then I only have to make it at one place. Now, having said that, you might say, you know, actually, I like it mostly in everything, but in this one particular case, I want to override it. I actually don't want to use gold for H1 in this one section. I'm just going to make it to red. Okay, not too creative with colors today, right? So red, right? I'm going to make it red. You can still use the inline styling, right? So that's your way of doing override. So I can have like a style sheet, or I can specify at the head what I want for all of these. But then like within the document, let's say the H1, I can go in there and make it whatever, pretend this is not a P here, right? And I can make it like some other color, red or something like that. So I can still override, right? So the nice thing is that you can have like this generic style that cascades to everything, and then you can still override it at the particular line level if you want to. Okay, so that's a really nice way to be able to manage large numbers of sheets with like one style, right? So that's the way, that's the idea or thinking behind CSS or cascading style sheets. Okay. Let me go back to here actually 1 second. So the other thing is, I don't know if it's apparent to you, but let me kind of state it if it's not apparent to you, right? So the way it works, whether it's in the style sheet or in the head, the main thing is here. You're talking about like these, I would say like categories or tags that you're going to associate these styles next to it. Okay. And you notice things like this, right? The curly brackets here. And just notice like it's slightly different in terms of how you approach it, right? You can see that colon here. And you can see here, not the colon, what was I saying? Curly brackets versus like the double quotes here. Okay, so a slight difference, right? I mean, you probably like looked at it so quickly you didn't even think two times about it, but it is different. So sometimes people kind of mix these things up, and they'll kind of mix up these curly brackets and quotes here like that. So just remember that it's slightly different, right? And like I said, inline is particular, it's within the tag, like in this case, P, right? In this case, you're taking like a tag here, and then with that tag, you're associating like the attributes or the style that you want for that particular tag that you want applied across your whole document. Okay, so just in case people didn't really notice that, I'm just kind of pointing out that difference. Okay. So as to why is there a semicolon after this? I think that's just like syntax. There's some things with HTML, they've kind of like upgraded HTML over the years. So right now we're up to HTML5. You know, there's certain things sort of like semicolons or whatever, where they kind of require to kind of tell the computer explicitly that you're at the end of a line or something like that. So you're saying, okay, I'm specifying, you know, like the style, right, for background color, let's say, right? And then there's like a semicolon, it just says that's a pair. You can argue whether you really need that or not, right? And I think over time, like HTML has evolved that, you know, you don't need some of these extra things to kind of tell at the end because it's kind of apparent that's at the end. But at the same time, if you want to maintain sort of like backwards compatibility, you kind of put these things in there, right? There's some unnecessary things, like even like in the head, where am I here? So car set UTF-8. I mean, does it really break anything if you don't put it in there? I haven't seen it break anything if I don't put it in there. But you know, I think there's things that people kind of put in there, make it more explicit. Sometimes you don't know if you don't put something in there explicitly. Let's say we go up to HTML6 or 7 or whatever, like you kind of make some changes there, and the default behavior kind of changes. And if you don't state something explicitly, then it kind of changes, right? Whereas like if you go in there, even though right now you don't really need to put that in there, you put it in there, make it explicit. So later on, if they change the language, you know, it will be somewhat backwards compatible, assuming that they support that particular function, right? So it's the same thing here with the semicolon, okay? So I think, you know, I don't think you'll actually break anything without it, but I think historically, like that's the format or the syntax you go with. And I think to make sure that it's backwards compatible, you should maintain that, okay? And you'll see some of that with JavaScript also. There's some stuff that you kind of put in there. It's not 100% necessary, but it's backwards compatible. And I'll kind of mention that with escape characters too. You know, there are some cases, escape characters, or you don't really need it. It's fine, right? But you're not quite sure sometimes, and you just don't want to. It's a way of playing safe. Just go ahead and do it, and you got yourself covered. Okay. Sorry if I'm making a long-winded answer to that. So here's the thing, right? So you have CSS files, and it's really the same thing, right? So whatever you had up here in terms of specifying like all of these different attributes for the tags, you just kind of put in a .css after it, and you could call it whatever. And you have this one line here, and you can pull that in. It's the same thing as putting it into your head. But the reason why you do this is so that you can have multiple HTML documents point to the same style sheet, okay? But other than that, it's the same kind of way of doing it in your head here, like this. So let me show you a style sheet. So I set up this like that. Okay. So this one has a little bit more, like, don't worry about this nav bar stuff or whatever, but like the body. Okay, so you can see, right? You can, essentially this padding is kind of like your margin. You have your font and put some color here and your background color here. Okay, and this is in hex. So let me go back to here. Here's my style. And I have this here. So it's in the same folder, right? You can see I put it in the same folder here. And so the only thing you have to do is do this. You say you're going to do a style sheet, and then your reference is mystyle.css. Okay. Let me see here. So which one is this? Sample with CSS. Sample with CSS. Double click, and you have this. Okay. Just arbitrary, right? Just some color and whatever, right? So you can just see how like a style sheet would work. Okay. Point being is that it's essentially the same type of thing as what you use in your head, but you just store it into a file so that other HTML documents can reference it. Okay. Let me go back to here. Chapter 4. Okay. Yeah. Okay. So at this point, you can use both, right? You can use a CSS file and you can use the style tags in the HTML file. Okay. I shouldn't say on there. I think that should be in, right? So in the HTML file, I can use the style tags in the HTML file. Okay. And it was like the same thing I was saying before. You can have the generic style that applies to everything, but then one particular thing you want to override, let's say for that document or for that particular inline area, then you're going to override it. You're welcome to do that. Okay. So all of this kind of fits together nicely. Okay. So here, this just kind of shows the example here, a couple different things here, and showing the resulting style here. Let me see if I did something here on HTML5. Same type of thing, right? I basically did this here, and it kind of shows up over here. You can see, right? Something like that. So yeah, just some examples you can play around it, but the main things are really, like I said, the colors, the fonts, the size. You can play around with those. All right, so now escape symbols. So, if you have like, and you'll see this more in JavaScript, if you have something like, let's say these tags here. So I actually set this up example here, like this. I don't know, for the sake of argument, you're doing like some sort of document about HTML, right? And so instead of where you have this like H1, like instead of using it to actually do the format, you actually want to show H1, right? You want to show the H1 here. Then you use these ampersand signs as your escape character. So this is like your less than sign here, LT, and then GT is your greater than sign. Okay, so if you don't put these in here, when it renders it, it's going to get confused as to like, are you using the H1 tag, or are you doing, you actually want to print out H1. Okay, so you can see here, like I did this, right? So normally you're kind of thinking, oh, well, here's H1 and here's H1, and then here's like, something I want to print out. I want to print out /H1. Well, they don't really know, like, is it this one I'm doing or is it this one I'm doing? So by doing this with the escape character, it allows you to print out the H1 like that. And I showed it to you when I just went into the sample H1 here. So you can see this is the H1 that I put here, like that, okay? And this one, it didn't print at all, right? Because it kind of got confused as to like, what's the closing tag for this? Is it this or is it this, right? It doesn't really know. And so that's why I didn't print it out. What it printed out was this one. Actually, let me do this then, just so it's more clear. Right, so it's H2 now, okay? So this is how you're able to kind of show these special characters. It's not that many special characters, but there's a few of them. Oh yeah, I put in the resource for this. You can see this. This is a CSS tutorial if you need more to go through this. So it goes through each of the steps, which is pretty good. So it goes through like adding colors, adding fonts. You can put a navigation bar, styling links. Don't worry about the navigation bar. If we ever kind of have you do it, we'll set up the style sheet to put in that navigation bar. So you don't have to worry about creating navigation bars or anything like that. But doing like colors and fonts are pretty straightforward. So you should be able to do stuff like that. So if you go through this page, which I added on to the resources page, you'll be able to cover a lot of the stuff that I just covered with handling styling and stuff. So where was I at here? Oh, no, actually, that's not what I want. I wanted chapter 4 again. So if you look at it, it's not that many, right? So like this and this, right? Obviously the ampersand is that, and then doing stuff with quotes. There's some stuff with quotes that you have to be careful with on the JavaScript, which I'll get into, so I won't go into it right now. But you have a couple of these different things. I actually never really had a problem with these things down here as being like special characters, but I guess it's in there, right? Most of the time, it's these things that I'm messing around with here. Okay. Yeah, so putting a space in here, right? So you can put in a space here like that. Okay. Does content not need to be in a paragraph tag? No, it doesn't need to be in a paragraph tag. Some people like to put that in there to kind of create paragraphs, right? But I've done kind of the same thing by putting in like the carriage returns, right? So I put in whatever into quote unquote a paragraph, and then I put in a carriage return and move it down. But again, some people might want to put different styles in there, right? So it depends on what you want to do. If you want to kind of wrap up something into quote unquote a paragraph and then apply a specific styling to it, well then yeah, you want to use the paragraph tag. But if you're just using like regular characters and just printing it without any styling, and you're just doing it very quickly, I have to say a lot of times I didn't use the paragraph tag. But I can see where you would use the paragraph tags if you want to do something and act on it as a paragraph. You can do that. But for my simple type of stuff, I would just kind of type in whatever, and then I'll use my carriage return to handle the spacing, right? In some cases, maybe I'm doing stuff with the space like this, right? And that's basically how I handle it, kind of moving some things around. The other things you can do is like alignment, right? So if you want things to be aligned to the center, to the left, to the right, top, bottom, whatever, you can work with that, let's say as a paragraph. Okay. Okay. So list tags. So you're going to have some number of things that for whatever reason you want to show a list of stuff, right? So you just have to understand the format here, right? So this UL is basically to tell you that this is a list, and this is explicitly an unordered list, right? So you're just saying it's an unordered list, and you're just saying it's like, you say it by saying UL, right? LI is like the individual items within that list, right? So that's all li means, okay? Well, that's what this is saying here too. So items are enclosed, are these are individual list items, okay? So that's kind of fairly straightforward, right? Now, things you want to kind of think about, like when you're studying for these things, it's one thing to kind of say, oh yeah, I'm going to study, here's like your bold, here's your italics, here's your underline, whatever, right? But you know, these tags, they can work together. You can put them together, right? There's like nesting you can do, right? You can make it bold and italics, right? You can put this stuff, I'm going to get the tables in a second, right? But you can put this stuff within tables, let's say. So there's all kinds of stuff. So don't think about it just to say, well, you know, here's a list, and that's it. That's how I study for it. Think about it saying, is it possible for me to put a list inside of another list, right? Or which you can actually, right? You can kind of do some nesting, although I have to say it does get really confusing if you're not careful with it. But do think about that, because it does come up in real life, and it's probably going to come up in the exam too. So don't think that, well, I'm going to study this and say, oh, I know how to do a list and that's it, right? Think about it saying, well, if I actually had to do like some other HTML, you know, tags within that, how would I do that? Would that work? Right? This one's pretty straightforward, where I say, oh, what happens if I want to make this bold? Well, you guys know you're just going to put a, you know, tag here and a tag here, and you'll make it bold, right? That's kind of fairly straightforward. But then you might get a little bit more confused if I say, well, what happens if I want to put one list inside of another list, right? So food for thought, think about that, because it is something that you're probably going to see, okay? But I'm showing you the general structure right now. It's UL, right? And make sure you don't forget the /. And then within that, each of the individual, I call it elements, but that's probably not the right way to call it. Each of the items, right? So each of the items in here, okay? So hopefully that's fairly straightforward, okay? And so the main thing is you see these little dots here, right? Here. Now, the next list that we would use is OL, right? And that's called an ordered list, right? Kind of the same thing, right? You can see these LIs in here, right? These are each of the items. Main difference is that you see these numbers here. You can see like 1, 2, 3. Okay. So you'll kind of have these. You want to make sure you understand how to do these things. And you know, my suggestion is to do things like nesting them, right? So look at this. Here's nesting, right? So you can see here's the dot, right, for the unordered list. But then within that, we have the numbers, right, for the list, right? And you can see how we did the nesting here, right? So you can see the UL on the outside. And then within that, you don't just go straight into like the ordered list here, right? I think that's a mistake that a lot of people do, where they'll start off with the UL out here to get these little dots here. And then they'll forget to put this LI here to say these are the items, right? So that's what you have to do as part of your nesting, right? So here's your LI here, that's your item to say, this is my item. And then you can put this here to set your list here. Now, when I show you how to do a table here, you can imagine what happens if I tell you to put a table in here, right? So then you want to put the table in here, right? So what does the OL do? So OL is this other tag here, right? So this is your ordered list, like this, okay? So UL is unordered list. OL is your ordered list, right? So I don't really want to kind of try to think of all the different combination of things you can put together, but I'm telling you, like what we show you here is kind of like the little building blocks, but you can put these building blocks together in a lot of different ways, right? And that's what you see kind of in real life too. And, you know, frankly, there's other people that do this for a living. That's their job. And what they'll do is they'll try to package things up so that you don't have to think too much about it and just say, oh, this person already did this already. So I'm going to just use their library or use their style sheet or whatever to get to this. But you should still understand how to do this and think about, how do I put these different components like Lego blocks and put them together. Okay. So like I was saying, we've done this in the past before. I've seen a lot of people make this mistake where we do the nesting like this. You have the New York, right? And then this is like the dot for the unordered list, right? But then for the ordered list, they went straight into the OL, right? They kind of say, oh, here's the next thing. I want to ordered list. So let me put the OL here. And they forget to put in the LI here to show the element, not the element, item. I keep on saying element. I shouldn't say that. So the item, okay? So it's like this, right? Now, this is an example that we kind of show here, but like I said, I could have just as easily said, oh, what about like a table, right? Like I said, I'm going to get to a table in a second, right? We could put a table in here, and within table, there's a similar concept, right? You can see like a list. Here's like all the different items, right? Within the table, you have this concept of rows, right? So you can put rows within a table. Same type of thing. Can I put different things within each of those rows of the table? Yes, you can, right? So think about that because we're going to probably ask you like those different types of things. How do you put these different pieces together? And you have to remember things like this, okay? Or play around with it, right? Just play around with it on your browser and you'll see how these different things interact, okay? Here, okay. Yeah, I'm not really sure, like, I kind of work with this too much. I mean, it is what it is, right? So you want to kind of have like this, what do you call it? Like sub indentation or something, right? So like it's like a sub list or sub, it's just indentation really, right? So in this case, right, you have like the Superman here, and then you kind of like the next line, you kind of like indent it, but it's part of like the Superman content, I can say, right? So I have to confess, I don't really use this too much, but this is something that you can do, right? So as it says, right? So this part will be the definitional term, and then this will be the data, right? So it's I like to think of it as like, here's like the main topic, and then it's like a indentation, and then talking about like something about the main topic, okay? Yeah, again, I'm not really sure how often you would use something like this, but it's out there, okay? So that's the definitional list, okay? So I won't spend too much more time on that one. So this is like where you talk about like linking like a picture, right? So like in this case, you're talking about a JPG here, right? So you have something, right? When we were doing like HTML assignment. So one of the things that we cut for the semester or for the summer really is the HTML assignment, because I kind of tried to figure I can maybe squish them together with the JavaScript in one shot. So, we don't have that like HTML assignment. What we did in the HTML assignment was do things like, you search the internet, you find like some images and then make it so you can click on the image and then go to a website and stuff like that. So I cut that out for the semester, but it is something you should still understand, so you can make sure you can do it, okay? So like it says, right, here's the source, right? And the file name is really the file name of the picture, right? Or in this case, the URL of where the picture is at. Right, so this is not a local file. This is not you running a website and you have a picture locally on your computer. You went out into the internet, you found the picture, you're gonna reference that picture. So you're gonna essentially put in this like that, okay? And tying this back to last week where we were talking about absolute and relative path, this will be your absolute path, right? So you're essentially looking at absolute path when you're going onto machines that are not yours, right? So this website is not mine, right? When I look at relative path, it's basically like I wrote my website, I put into a certain file system or folder, right? And I'm looking for like a picture that's either within the same folder or maybe it's down one folder from me or up one folder from me. And I put in a relative path because it's on my machine, it's local to me, right? In this case, it's not. And that's why anytime you look for something that's not on your machine, you're basically going to put in the full path, right? Absolute path, because you don't know where this is going to be, right? It's not relative to my location. I don't know where this is at. So I need to put in this full URL here to get to that image. Okay. Right? So you put in it, basically saying, okay, you put in the image where the tag is at, and you can like do things like align it, or you can put sizing to it. You can specify the height or the width to it. Let me see if I have, oh, so you can see here, right? So we put in a width of 250 on it here, okay? So this is like the different floating, right? So float left or float right. This basically just talks about like the text, like how does it flow around your image here, okay? Does it flow around to the left of it, to the right of it? So that's what, when you talk about the floating around it, okay? All right, so last part, I know I've been holding you guys for a while, so we're up to the hour point. So, but hang on, the tables is kind of important. So let's kind of stick with this a little bit here. Okay. So I mean, I'm sure you guys all know what a table is, right? So you have a table. You've probably seen it like an Excel spreadsheet or something, right? And then you have like these rows here, right? Like these rows here, right? And like each of these is like a cell here. Okay, so this is very basic. This is like standard like table HTML, right? Obviously, you probably see much prettier versions of this with, you know, with the styling and whatnot. But this is a standard default table here. Okay, and the top part, you're saying the table, and just like you saw on the list, you can see these TRs. That's your row, table row, okay? And you can see there's like a special thing for like the top part where, let's say the header, you want to make it bold or whatever, right? So similar to your H1 to H6 on your regular text, right? You can put in like this TH here, right? TH. I draw the analogy to your H1, right? It's not quite exactly the same, but it's pretty close. So it makes it bold across the top like that, okay? But still, you can't have that TH by itself. The TH is controlling each of these elements here, okay? It's still enclosed within a TR. So the TR, this is essentially telling you this is the first row of the table. Okay, and you can do things like maybe having like you know, like nights and cost per person, like put that together and span it across, right? I'll get to that in a second here. So within the rows, right, you have the TDs, right? That's each of the individual data elements. So that's these guys right here, each of these individual items here, right? With the exception of the top row where each of those individual items, we're calling it TH, right? To make it bold like that, okay? So here, you can do these couple of things to make it special at the top for the column heading. And then like what I was saying here, you can make one of these span across the two. So in this case, oh, they've already done it. Okay. So you have the country, and look at this. You can see the languages spanning across these two. Okay. I'm saying spanning, but don't confuse it with the span that I was just talking about for up here, like when I was talking about the regular HTML part here. This is specifically for the table, right? And of course, it doesn't say span, it says col span, right? COLSPAN, right, is two, right? So that tells you you want the languages to go across these two columns like that, okay? So I'll break this down for you. Just well, I'll talk you through it, right? Okay. So here you have the table, and then you have the border, right? So border equals to 1. So that's like this, right? You can see that. And like the caption here, this is outside the table, although it's part of the table. It's like sitting on top like this. It's almost like the title section, or I guess caption, right? Is right at the top here, right? So when you say caption, this is what you're doing, right? So within the table, you have each of your rows. Outside your table, like, I don't know, the name of the table or something, you put caption like that, okay? And don't forget TR, right? So the next level down, you have to remember each one of these you're working with is a TR, okay? So you have a TR here. And then within that, you're going to use the TH, right? So the TH, right, that makes it essentially like your regular HTML, your H1, okay? And then here's your column span. So that's your column span, right? Two of them, right? And then going down these are more normal, right? This is just like cookie cutter type of stuff, right? So here's your rows for the table, and then TD, which is your data element, right? Belgium, Dutch, French, right? Belgium, Dutch, French, and take it all the way through, okay? And so I think there's a really actually a pretty comprehensive example or starting example for a table. You know, what I might ask you to do as part of your online work. I can't really give you that much of a break today, so let me just give you a couple minutes. You can finish up the table on your own. I think it's important. You do this table for your own online notes. I mean, for your own notes to study for the exam. So do this, and then, you know, see if you can do some different things in here. Maybe you can put in bold. Maybe you can put in italics. Maybe you can even try to put a list inside one of these here and see what happens, right? Get used to the idea of like nesting or putting together different tag or components together and see what happens, right? So I'm going to assign that to you as your online classwork for today. Work up your own tables. You can copy exactly this right here. Just type it in. If you're going to be lazy about it, you don't have to put in all these rows. Just put in 2 rows or something. That's good enough for what you need to do, right? So put in all of this. Put in these couple of rows here. You don't need to put in the last rows. And then try putting in some other tags in here, right? Put in, if you understand what I just explained about like putting in an image, put in an image here, right? Put in an image into one of these, put in a list into one of these, either ordered or unordered, whatever. Try to nest a couple of stuff in here and see what it looks like, okay? You can send me a picture. If you feel like it looks kind of screwed up, you can send me the HTML too, and I can take a look at it and like walk you through it, okay? So let's take a 2-minute break and, you know, go ahead, do that. 7:05 right now. Yes, you can do it without any restriction, okay? So take 2 minutes. It's 7:06 right now. We'll come back at 7:08. And you don't have to turn it in to me just exactly at this moment, but try to turn it in sometime tonight. Send me like a picture of the output and, you know, the HTML itself if you feel like you're stuck on something, you're not sure what's going on. Okay. All right. We'll be right back. Hi. So I'm gonna save a copy. I already saved the PDF for this onto Canvas, but I'll take this table example explicitly, and I'll just save a picture of that and put that out into Canvas also. Okay, so people can reference just this page alone if they want to. Okay. Okay. So if you don't mind, I'm going to close this. And I think I closed this. Okay, so where am I at? Okay, all right. So, I know a lot of you probably aren't thinking that you came to this class for a history class on computers, but I did actually cut some stuff out here to make it a little bit less like a history class. So hopefully we're okay with that. I'm gonna go side by side on this. So let me see. Where am I at here? Oh, wrong browser here. Course objectives. Let me pull this out. Okay, so let me make this bigger first. So you can see I put in a line. So I'm not going to really kind of make you identify like what are the 8 most important developments in digital computers and ask you to give me a timeline on it. In the regular semester, we would have asked you to do stuff like that. Or talk about the advantages that came from each advancement, right? So what I'm going to do is I'm going to try to kind of go through this just so you kind of get a flavor of like the timeline and a flavor of like what the benefits are, but I'm not going to make this like where you have to memorize like, a timeline, a date or something like that. But do try to understand like the concepts and hopefully that will be sufficient and not too taxing on you because I know you have a lot to digest to get in for the exam. Okay, so this is what I kind of highlighted here, right? So I'll say, okay, if I tell you about these 3 names, just kind of tell me a little bit about what they did, but you don't have to tell me when they did it or, anything like too crazy like that. Okay. So let me get into the PowerPoint here. So let me close this so I don't get messed up. I don't need to save that. And here. Okay. So let me get this up to size. Okay. So yeah, basically you talk about computers, let's say back in the mid 70s, you're looking at like these kind of boxes, right? And actually this is pretty good, right? Like when they talk about personal computer or whatever, or in this case, mini computer, like this looks like a pretty big piece of equipment here, right? But when you actually looked at like the mainframes or the IBMs or whatever, they filled up like entire rooms, right? They were like ginormous. And they had nowhere near the storage or the computing capacity that the current computers have right now. Okay. So, so let's kind of go through a couple of these different things and I'll try to emphasize what's important and some of that stuff is just nice to know. Okay. So I guess you can read this. I'm not going to repeat all this stuff here. Early computing machines. Okay. So Babbage is one of the first names you want to know. Don't worry about like these dates in particular, right? Just kind of think, yeah, a couple hundred years ago, right? And basically kind of worked out mechanical computer, Okay, this is an example of that computer. Okay, and here's another one, right? I guess the only, maybe the other, so this has like a lot of the principles of what, we would have right now, right? You're talking about they had a programming language, there's like a memory, they had like printer, they had punch cards. I'll talk a bit about punch cards in a second. Okay, so Holleriff, right? Herman Holleriff, this is pretty, the main thing you want to kind of remember is the idea of the punch cards and applying computers to do the census. Okay, so before they did the census by hand, right? So before he came along, they were doing it by hand. When we're talking about the census, we're talking about the census for the US. And once he digitized it, right, using these punch cards, obviously there was more people to process and whatnot. And instead of taking 8 years, he did it, or not he, the computer did it in about a year. Okay, and the big thing is using these punch cards, right? And if you remember, like within the first week of lecture, we talk about the idea of presence and absence, right? So you talk about zeros and ones. So presence and absence, that's a part of this, right? So their binary version, their binary thing is either absence, right, or presence, right? So you have something or nothing, right? There's only two states essentially, right? So same thing with these punch cards. Okay, so this is an example of it. Okay, and basically just representing the data in zeros and ones. Okay, so that's a big step there. So don't sweat too much about this, right? I mean, vacuum tubes are vacuum tubes, and this is like these room-sized computers I was talking about, huge amounts of power and whatnot. I think they were probably pretty hot too. And there was a big jump from the vacuum tubes into transistors, and then ultimately into integrated circuits, right? And all that really, you can see like this picture up here, right? You can see like, from left to right, how things got smaller and smaller, right? And how things go, right? Where, things progressively over time, it's getting smaller, but at the same time, it's getting more powerful. So that all kind of came about from these major steps, going from vacuum tubes to transistors to integrated circuits. So yeah, so here's what it looks like with the transistors going from this, right? That's pretty big and bulky. Then you're going into the transistors, and then you're going into integrated circuits. Okay, so I wouldn't go into like, okay, what specifically was good about the vacuum tubes and then the transistor and this, right? The main theme you want to recognize is that it's going from big, bulky to smaller and smaller. Okay, right? So, this is still pretty large by today's standards, right? Right, you get into microprocessors, you can see it's getting progressively smaller and smaller until finally you get to the point where you can have like in this case, we were talking about Xerox, right? And remember, again, this is something that kind of catches up a lot of people, is that, the mouse, the graphical user interface, it came from Xerox, but really from a commercial, like personal computer usage. Really, Apple made it what it is today, right? So they essentially were the first successful company to commercialize it, right? So that's why everybody thinks of Apple as the one that invented this, but really it came from Xerox. Okay. I'm busy. So this was the picture from before, is like showing the mini computer down to the personal computer, right? The first electronic spreadsheet, VisiCalc. Then, ultimately you get to the spreadsheets that we see today with these type of things here. Apple was out there, and then IBM came along with their version, right? And then there's like this whole thing between Apple and IBM, personal computers. And it really continues to today when you look at Apple versus, let's say, Android. It's just a little bit different philosophy when it comes to computing. Okay, and so these are the major pieces when you look at a computer, right? Obviously, there's input, right? It could be your keyboard, could be like a scanner, could be like a camera, whatever it is. There's some input coming in. You have to store the information somewhere. It could be stored on your local computer. It could be stored on the cloud, wherever. Like, it has to get information from somewhere. That's like remote storage, right? Like if I store it on a hard disk, or I store it on a memory drive, or I store it on the cloud somewhere, that's like essentially remote storage. And then you have like local storage that's much closer to the processor to do work. This doesn't really distinguish it. It just says storage devices, right? But we'll get to that in a little bit. So then you have the processor, does some calculations, and then you have output. Output would be something like, your monitor, maybe it outputs it to like some other storage device, maybe it outputs it to a printer, whatever. So these are like the major aspects or pieces of a computer. So like I was saying in the beginning, mechanical computers, right? Like this, right? In case you guys don't know, this is like a slide rule here. Frankly, I actually don't know how to use a slide rule myself. Actually, I don't even know how to use an abacus, right? But as an abacus, like they have these in museums now, I guess, and whatnot. Maybe it's laying around your grandparents' house or something like that, right? You have these things laying around, mechanical computers. Then you get into hardware with electricity and whatnot. And now you have the personal computer coming along. And then, of course, most recently, pretty much everybody's doing a lot of these things very small, right? It could be on your phone. It could be, embedded into your body, right? Whatever, right? It's very small these days. I'm not going to break down each of these different things here as the pieces of your phone, but the idea here is just it's getting smaller and smaller, right? And more of the stuff is integrated onto like one chip or one area as opposed to like all these separate components. That's all part of like getting things to a much smaller footprint. Okay. Layer software stack. The main thing you want to know with this is like you have like the different layers. Most people is going to be up here at the application level, right? So you don't particularly care like what is the underlying operating system, right? You don't care about all these different things, although everybody has all of this stuff. Like for all of these things at the top to work, you have to have all these different things at the bottom. These are your foundation, right? These are foundational components. These are the things where, I say, oh, save this or print this or do whatever. This is how your computer knows what to do when you tell it to do that, right? If I tell it to print out my document, you don't need to know exactly what it does to tell the printer to print because that's all built in down here, right? So that's the idea of the software stack. Just like during the first week of class, I talked about you have a car, you step in the car, you step on the brake, and the car stops, right? You don't really need to know how did the brake stop the car, right? It could be like some mechanical thing that connects the brake to like the brake shoes that are on your wheels. It could be just sending an electrical signal, right, to tell the brake shoes on your wheel to stop. You don't really know, and you don't really care for the most part as a normal person, right? But that's the idea of abstraction, right? Abstraction kind of takes away the underlying complexity and presents only what you need to know as a typical user, let's say. So if you're a typical driver, I'm not going to tell you like all the different things that are behind like the dashboard that, monitors all the different systems in your car. It says that if your car is like too close to another car, it'll step on the brake, or, the car is going to go in reverse, it detects something and it stops or whatever. You don't need to care about that, how that's implemented as a typical driver. So that's like levels of abstraction, okay? The other thing is algorithm. This is where you, it's almost like a recipe, right? So you have a recipe, you kind of tell someone to how to bake a cake, right? How to bake a cake. So you have to get all these ingredients, you have to put them together in this certain order, you have to like stir them, you have to cut them, you have to do whatever. All of those different steps is your algorithm on how to make a cake, right? So by the same token, you have to tell the computer to do something. So you have to present this algorithm, and usually people will come up with the algorithm and then translate the algorithm into code and work off of that. So that's what your assignment is going to end up. So in case you don't really know, what's going to happen is we're going to develop pseudocode, we're going to develop the algorithm, and then we're going to look at how to implement that algorithm into real code. Okay. Yeah, I'm not really sure about this one, abstraction. I think like the example I just talked about with the car is probably a little bit better idea of what abstraction is. But these are some other stuff that came about with respect to abstraction, okay? And algorithm, right? So this one is a cookie recipe or a brownie, pizza brownie. So you have all your ingredients here, how much of those ingredients, what you have to do to the oven to prepare it, what you have to do to mix the ingredients, spread it out, how long you cook it for, or bake it for, I should say. And then you get a pizza brownie on the other end of this. Okay. So that covers this part. Okay. I don't know if there's any questions on this. Gonna see if I can catch a little bit of the next part of this so that we can kind of have almost a clean split between the first exam and second exam materials. Otherwise, I might have to pick up some of this into the second exam. Not second exam, the Wednesday. The beginning part of Wednesday, I probably will cover a bit of this now that I look at it. It's going to be a little bit difficult for me to try to pick up all of this for today. Okay, so let me just give you kind of an introduction here. All right, so chapter 9, again, the idea of layered software development, software layers, and then like actually within your computer or specific around like your CPU, what are the different things that's happening? How is it processing information? Okay. Probably in practice, you probably don't have to worry too much about it. You're probably going to be able to, do your HTML or your JavaScript and whatever else you need to do just fine. So, again, this is maybe just, for your own like understanding of how your computer processes information, how it does calculations. Okay. So your processor, basically all of the stuff that was part of your recipe, your algorithm, like that's cranking through, your processor is going to pick it up step by step and follow that, right? There has to be something that obviously feeds the processor or feeds the CPU, feeds that information to do work, right? Then, like I was saying before, like the operating system. So like I was saying before, if you have a document, you say, okay, I want to print this document. What do I have to do? You don't have to really do anything, right? You just tell the computer, I want to print this document. right? But behind the scenes, the computer has to know how to print it, right? So they have these things called like, we don't put it on here, but they're called device drivers, right? So on your computer, like how does your computer know how to talk to XYZ printer, any type of printer, right? How does your printer, I mean, how does your computer know how to, interact with your monitor, right? Or TV, probably your monitor, to display something, whether it's like, like a big fancy monitor, like big wide monitor, like whatever. It's like all kinds of different monitors that are out there, just like there's all kinds of different printers. You're going to have like these different what they call device drivers that allow the computer to talk to different things, right? Maybe it's to save information, maybe it's to print something, maybe it's to display something, like all these different things. You as a user don't care, right? But your operating system will manage all of that for you. If you say, I need to delete something, I need to save something, I need to print something, all of that goes through your operating system, right? And that's like one of the lower levels of this software stack, okay? Software are just programs, right? And they could be anywhere. Mostly at the top level, kind of people refer to them as applications. And that's like your games or Microsoft Office or whatever, right? And, within those, they all know how to be compatible with the operating system that's below them, right? They know how to tell the operating system that I need to save a file, I need to print something or whatever, right? So the instructions tell the processor what to do. There's a fetch execute cycle, which I'll get into. Memory to store the data, right? And this is where you have different types of memory. You have the memory that's on board with the CPU. You have the memory that's kind of just in general, like local to the computer. Or you have like memory that's kind of like far away, like just remote storage, okay? And hardware is just like the physical parts of the computer. So we have a picture here, right? So I call it remote storage. It's called secondary storage here, right? So secondary storage, okay? Here's your input, okay? Whatever you did, maybe you added two numbers together or something, right? This is your output here, right? And then here's like your CPU processing stuff here, right? And then within here, you have like your working memory, okay? Which is different from like this other memory, which they will call secondary storage, okay? So this is like fast memory. This is like, what you're working with right there and then within your computer, right? So if you have to add two numbers together, your two numbers are going to be sitting here. They're going to do something to it, add the two numbers together, and the outcomes here, right? But now if you want to store the output from these numbers, or you want to take the input from these numbers, you have to get them from somewhere. They're going to be here in this secondary storage, right? This is not meant to store a whole bunch of information, right? It's only meant to store information that your CPU is working on right there and then, okay? Just 1 second. Sorry, got my family running around me here. So anyway, and so what I was saying, you need to have something that kind of controls things, right? It's kind of like the supervisor that kind of coordinates things. That's what this control unit is doing, right? And then you have to have like these like worker bees or something, right? This is like the thing that actually does the actual calculations. So that's how all the different pieces all kind of fit together, right? And you have it under your readings here, right? And this kind of almost is like a rehash, but it gives a little bit more detail, okay? So here's like, this is like your random access memory, okay? And here's your secondary storage or your storage device, right? So note the difference here, right? They kind of put it here, temporarily and permanently, okay? So you can, like I said, you can consider this to be like things that you're using to get fast access to, and you're working working on it most immediately, right? This is more, has larger capacity, but it's going to be slower. Okay. Now the truth is, over the recent years, there's actually been less need for people to need to use a hard drive, right? Because of the way things have been getting smaller and smaller and getting more and more powerful. A lot of times people right now are using what they call solid state drives, which there's no moving parts, right? That's why it's called solid state. Solid state drive, which it's fairly fast to read, and it's nearly as good as what historically you use as your local working memory. Okay. Your CPU, that's what cranks your processing things, right? So you have to get the instructions, right? So first you get the instructions, and you have to get the things that you're going to be working on. And then you're going to be working you're going to be adding stuff, subtracting stuff, whatever. And then this is your input output. So you have your keyboard, your mouse. You can output things to your monitor, to your printer, and whatnot. Okay. Back to abstraction again. I'm sure you guys are tired of hearing about abstraction, right? But data is processed, and there's different levels of abstraction on this, right? We're getting to fairly low level type of stuff here, okay? So here you have the control unit again, right? I consider control unit almost like I said before, like the supervisor, right? So you have your program, here's all the instructions. So you have to get the instruction, right? What's the next thing I have to do? I have to add two numbers together. What are the two numbers? Well, I have to go fetch the data. So I have to get number 1 and number 2, right? And then I have to execute the instruction, right? So the control unit is coordinating or managing or supervising all of this, right? So it says, what's the next instruction I have to do? What's the data that I have to act on with those instructions? And then go and, basically tells the ALU, their arithmetic logic unit, to do the work, right? And so they're going to perform the math here, and it transforms it. Transform it means basically just like, add one number to another, let's say, okay? So registers, this is like memory that's right on the CPU chip, okay? This is the closest memory that you have to where all this work is going. This is like what I was saying before. This is your working memory, okay? So this information is copied back and forth, right? Because it's not meant to be a big piece of memory here, and you're gonna do your work. Once you're done with it, it just kind of flushes it out, and you have like storage for the next bit of information that it's going to process. There's like a whole bunch of instructions that's cranking through this all the time. And then the program counter, that basically just says like which step in the algorithm are you at, and just, it's like a counter, right? 1, 2, 3, 4, 5. It goes to one line to the next line and whatnot. Okay. So like you see all these different things here where it says like move EAX and A, and move EBX and B, and then add these two together. All of that, like these moving instructions, they're moving things into registers. Like whatever the value of A is, right? I don't know, let's say A is 1 and B is 2, right? A is 1 and B is 2. You're going to load the value into the register, right? That's your working memory. Your register is memory, okay? So it takes these two, loads them up, and says, okay, let's add them, right? And note this point here where it says EAX accumulates, okay? For people that are not familiar with computer science, there's this idea of like accumulator, right? So normally like most people who are not in computer science, they'll think of things as like A plus B equals to C, right? But you can call it in terms of like efficiency or whatever. Like from a computer science perspective, a lot of times they'll just accumulate within the same value. They won't assign it to a third value because there's no need to create like a third memory location to store the results, right? So this is what they mean by accumulator, right? So they'll say location 1 has A, location 2 has B. When I add those two things together, the result of that, I'm going to store that back into location A. Okay, so right now, let's say location EAX contains 1. Location 2 location EBX contains 2. 1 plus 2 is 3. They take 3 and then they're going to overwrite EAX to make it 3. Okay, so even though on the outside you might look at it as C, internally they're actually kind of recycled that memory location to store that value, right? So that's what they mean when they say EAX accumulates, right? And then like programming computers, like languages, you might see something like A equals to A plus 1, right? So the variable A equals to itself, right, plus 1, right? That's how you increment things. So that's another way of showing that that memory location for A is accumulating, right? So A equals to A plus 1 or A plus 2, it doesn't matter. The result of that is stored back into A. And then the next time it goes around, A will start off at 2. So let's say A started off at 1. So when you say A equals to A plus 1, you get 2, right? Then it starts off at 2. The next time it comes around, A equals to A plus 1 becomes 2 plus 1, right? And then it becomes 3, and so on and so forth. Okay, and you're going to see this when we get into like JavaScript. Okay. So I'm going to, this gets into like a little bit this fetch decode cycle and the pipeline stuff. Not really sure I'm going to get through all that. So rather than cutting this off halfway, let me just introduce the idea of it. Okay. No, actually, let's not do that. So we have, this is like one way to think about it. I'm still thinking about food, I guess, right? So we have like this analogy, and this might be something that we would cover on the exam, where you kind of think about those different parts of the computer and draw some analogy to things that you're more familiar with. So if you think about this, like this is your refrigerator, right? That stores all the ingredients that you would be working on with your recipe to do something, right? So you can think of this as your secondary storage, right? So I hope people can see that that analogy there, right? And then you can think about like, well, here's your recipe, here's your cookbook, right? So you're doing stuff with this. This is your algorithm, or from a computer standpoint, this is your computer program that's telling me what to do. So I have to, it comes and tells me, say, oh, I need all these different ingredients. So I'm going to go to my secondary storage, my refrigerator, to go get stuff. And then here's like my countertop, right? So this is like my working storage. This is like my working area. So I can have easy access to the ingredients I need to fulfill this recipe, right? And then this is where you actually do stuff, your cutting board. Your cutting board is where you cut up your lettuce, and then you push them into like the next step, I guess, to your processing. Okay. So I think you might see some of this in here, but you can kind of think about how these are drawing analogies to like the kitchen, like doing stuff in your kitchen, cooking from a recipe. Okay. So I think we don't have that much time left. So rather than just kind of get cut off in the middle, I'm going to pick up the fetch, decode, and execute cycle at the beginning of the Wednesday lecture, and that will cover the rest of this. And this will be the last bits that will go into your first exam, right? So what I suggest you do is really just take a look at the sample questions and, come back to me if there's any questions on these. Sample questions, come on. Exam 1 sample questions. Work off of that. Let me know if you have any questions on those things. And look at the resources here and let me know if you have anything. As usual for the other weeks, like the other weeks, what I did was I put in like the old lectures I had from the spring semester where I broke them up into individual topics so it's easier for you to search them. But at the top, I will put in the whole long lecture that I'm doing also. Okay, so it's the same thing for these other weeks here. Okay, and of course the slides are in here also. Okay, so before I wrap it up for today, are there any questions?
No.
Okay, good. So do the sample questions covered all the general concepts? They don't cover all the concepts. There's only a handful of stuff that's covered on there. What's really going to be on the exam is everything here, right? And I kind of just did a quick flyby when I talked through the different things here. But basically, this is what you should be looking at. Everything that's in here is fair game for the exam. Okay. I will take a snap of the code for the table that you can refer to separately. It is in the slides that I post up also, but I'll just make a separate file just for the table as an example too. Okay. Cool. Any other questions? All right. Yeah, so like I said, feel free, pop me an email or whatever. I'll catch up to it and I'll try to get an answer to you as soon as I can. Other than that, it's been great seeing everyone and see you soon. Thank you.